So we are going to see PN junction, and in PN junction diode what we see, the P side and N side are sandwiched together. Now as the P side is having majority charge carriers hole, you see in the P side majority charge carrier is hole, okay, and N side majority charge carrier is electron. So due to the concentration difference, as in P side number of hole is more, so the hole starts drifting, that is hole starts moving from P side to N side, and the electron starts moving N side to P side due to the concentration difference. That is, the net current is from P side to N side, okay, because as the electron is moving N side to P side, so the current is opposite of the movement of the negative charge, or hole is moving from P side to N side, that is the current is from P side to N side. This current is called the diffusion current. This current is called the diffusion current. Now as due to the motion of the electron from N side to P side, what happened, the N side region is losing electron, so N side region gains some positive charge, okay, this upper surface, and the P side is losing holes, so this region is gaining negative charge, okay. So this is P side, majority charge carrier is hole, and this is N side, majority charge carrier is electron. So there is a potential difference between N side and P side, that is the electric field slowly grows up in the direction of N to P side. Now as the electric field grow from N side to P side, this electric field try to apply force on the electron opposite of its direction, that is electron starts now moving P side to N side, and the hole starts moving N side to P side, that is hole starts moving N side to P side and electron starts moving P side to N side. So the net current is in the direction of motion of opposite of negative charge. So as electron is moving P side to N side, so current is N to P. That current is called drift current, that is due to the drifting of the charge, and the diffusion current was due to the concentration difference in this direction. At equilibrium, that is drift current and the diffusion current is equal, so the net current is not 0, okay. So this net current is 0, okay. Now what you see, this region in which there is the potential difference is there, this region is called the depletion region. This region is called depletion region, in which there is electric field from N side to P side. Now P side is electrically neutral, so if we see, the potential is constant in the P region, and in the depletion region you see here it is negative charge and here it is positive charge. So we are moving from negative to positive, so potential increases negative to positive. Again in the N region potential remains constant, in the N region potential remains constant. This is your N region, this is your N region, this is your P region, and this is your depletion region. This region is your depletion region, okay, in which potential is changing, that is potential is increasing, okay. Now we will see when the diode is forward biased, what happened. When the diode is forward biased, basically, that is what we do in case of forward biasing. In case of forward biasing, that is forward bias, we need to decrease the width of the depletion region. So how we will decrease the width of depletion region? See, the width of the depletion region, that means we are going to decrease the potential difference between P side and N side. That means let us suppose the N side is having potential to 10 volt and this P side is having minus 2 volt. So what is the potential difference? 12 volt. Now if we want to decrease the width of this depletion region, that means decrease this potential. This potential is called barrier potential. This potential difference between P side and N side is called barrier potential, okay. So basically in case of forward biasing, we need to decrease the width. So what we going to do, we need to connect the positive terminal of the battery with the P side and the negative terminal of the battery from the N side. As we connect the negative terminal with the N side, so its potential was initially 10 volt, now it becomes 10 to, let us suppose it becomes from 10 to 6 and it becomes from minus 2 to 4. So now the potential difference is what? 2 volt. This is again positive, N side is losing electron and this is negative. So width of the depletion region, you see this is the depletion region. Okay, so this region is your depletion region, this region. So the width of the depletion region is what? Decreasing. So what you see in the P region, what you see, the potential in the P region is constant. Again in the depletion region increases this much. This is the barrier potential, and again in the N region, this is the N region in which potential is constant. This is the P region in which potential is constant, and this region is the depletion region. This region is what? Depletion region in which potential increases. Now in case of reverse biased, in case of reverse biasing, what we need to do, we need to increase the width of depletion region. That is, we are going to increase the width of depletion region. That means we are going to increase the barrier potential. So how we are going to increase the barrier potential? That means we are connecting the P side with the negative terminal. P side is having excess of hole, okay, and N side with the positive terminal of the battery. So if you connect the N side with the positive terminal, the potential difference will increase more. Initially it is 10 volt, now it is, let us suppose, 16 volt, and initially it is -2, now it is, let us suppose, -4. So now the potential difference is what? 20 volt. So the width of the depletion region, this is the depletion region basically. This region is your depletion region. This region in which there is charge, this region is the depletion region. So the width of the depletion region increases. So as the width of the depletion region increases, so in the P region the potential is constant. Again width of the depletion region increases, that is barrier potential increases. Again in the N region potential is constant. This is N region in which potential is constant. This is P region, and this is your depletion region. Okay, this one is your depletion region. This region is your depletion region. From here to here, from this point to this point, this potential difference is called barrier potential. This potential difference is the barrier potential. This potential is barrier potential. Is it clear? Now forward biased, that means what? This is an ideal diode, and this potential is A, this potential is B. If potential of A is greater than potential of B, this diode is called forward biased. And in forward biased, the ideal diode behave as a conducting wire that is having zero resistance. But in reverse biased, what happened? This side potential, let us suppose A, this side potential is B. This side potential VB is greater than VA. So this is what? Reverse bias. If the potential of B is greater than potential of A. So this is behaving as an open circuit. That means it does not conduct any current. That is, it behave as an infinite resistance. Is it clear?